In this video, you'll see how to monitor your service mesh container environment using Amazon Managed Service for Prometheus, or AMP, and Amazon Managed Grafana. With these services, you can ingest Envoy metrics from AWS App Mesh to a managed solution, visualize operational data, and monitor the health and performance of microservices. This is a Cloud 9 environment with the necessary prerequisites installed. From here, we'll run some commands that use the Envoy open source edge and service proxy to send metrics from App Mesh running on an Amazon Elastic Kubernetes service, or Amazon EKS, cluster to AMP. To get started, we'll export a few environment variables. Next, we'll copy and save an EKS cluster configuration file. Let's check the file to see if the cluster name and region are correct. Now let's create the EKS cluster and service account that will be used by the AWS App Mesh controller. We can see that 2 worker nodes are available. Next, we'll run a few commands to get the custom resource definitions, or CRDs, in place so we can install the App Mesh controller. The App Mesh controller helps integrate the Kubernetes cluster with App Mesh components. We can see the controller has been installed and is running. Next, let's create the AMP workspace. This workspace will be used to ingest the Prometheus metrics collected by Envoy. We can also create an interface VPC endpoint to securely access the managed service from resources deployed in our VPC. This ensures that data ingested by the managed service does not leave the VPC in our AWS account. We need the EKS cluster's VPC ID. To get this, we'll navigate to the Amazon EKS console. Now let's export the VPC ID and create the VPC endpoint. Next, we'll export the Helm charts so we can install the Prometheus server. The environment is set up, and now we can run a script to create the AWS Identity and Access Management, or AWS IAM role, with the permissions the Grafana agent needs to ingest the information to AMP. Let's download the script. We need to make some configuration changes in the script so that it understands the cluster name and other information. We can copy the cluster name from the EKS console. Now let's create the necessary policies and attach them to the right service agent. Next, we'll create a namespace so that the Grafana agent can be installed. Let's export the AMP workspace and then confirm that the workspace ID was successfully exported. Next, we'll export the IAM role that will be used by the Grafana agent, along with some other variables, and verify that the exports were successful. Now let's create a manifest file with the scrape configuration to extract the Envoy metrics and deploy the Grafana agent. We'll check to make sure everything looks good and then deploy the agent. After the Grafana agent is deployed, it will collect the metrics and ingest them into the specified AMP workspace. We can see the agent is running, and we can now deploy a sample application on the EKS cluster. The sample application is running. Now let's install the App Mesh controller. You can see a mesh was created, along with virtual nodes, virtual services, virtual routers, and services. Let's restart the deployment and then verify the envoys were ingested. Two containers are running in each pod. One is the mainstream application, and the other is the Envoy container. As you can see, the Grafana agent is now ingesting metrics into AMP. We can now integrate the metrics with Amazon Managed Grafana to analyze them visually and detect performance slowdowns or disruptions. To do this, let's navigate to the AWS Grafana console and create an Amazon Managed Grafana workspace. Give the workspace a name, and then proceed to the next step. Here, you'll define user and data access permissions. You'll need to enable AWS Single Sign-On, or SSO, for Amazon Managed Grafana if it's not already enabled. Next, we'll configure the IAM permission access settings. We'll indicate which data sources we want to consume and visualize data from, and specify any applicable notification channels. Next, we'll review the workspace configuration and create the workspace. Once the workspace is created, you can assign users access to it. We'll make the user an admin. Now let's navigate to the Grafana workspace and configure the data source. We'll select Amazon Managed Service for Prometheus as the data source, and then select the region where we configured the workspace earlier. Let's select the App Mesh workspace that we created. To analyze the metrics collected by the Grafana agent, we'll import a custom dashboard. We can see that the Grafana agent has started to collect and send metrics to AMP. The dashboard collects the downstream rate per second, count per second, latency, total collections, and more. You can configure a Grafana alert to be triggered when a metric increases beyond the intended threshold. Before creating an alert rule, we need to create a notification channel. Let's create an SNS topic and subscribe an email address. Now, let's return to the Grafana workspace to configure the new notification channel. Here, we'll enter the notification channel details. To get the topic, we'll navigate to the EKS console to copy the SNS ARN. Next, select the auth provider and then test the new channel. The test notification sent successfully, so we'll save the channel. Now let's return to the dashboard to create the alert. We'll configure an alert for downstream latency. Make sure to select the proper data source. We'll configure the alert to trigger when the downstream latency exceeds 5 milliseconds in a 1-minute period. The notification will be sent through the channel we configured earlier with a specific message. Let's test the rule. Everything looks good, so we'll save the rule and then apply it. After refreshing the page, we can see that the alert has been configured and the status shows as healthy. Now let's navigate back to the Cloud9 environment and generate a load to trigger the alert. As you can see, the health of the downstream latency is already decreasing. Within a few seconds, it goes to an alerting state. Let's go to the alert rule to get more information. The downstream latency has exceeded the threshold and has been alerting for a few seconds, triggering an alert to be sent to the SNS topic and subscribers' emails. You've just seen how to monitor your service mesh container environment using AMP and Amazon Managed Grafana. You can learn more about this topic in the description and links for this video. Thanks for watching. Now it's your turn to try.